I welcome you in this video on the chapter Probability according to ICSE Standard 10 Mathematics Syllabus for the year 2021 examination. This video is part 1 of the chapter Probability. The content of the video is introduction of the chapter with meaning of the word probability, followed by some basic terms and concepts with their meaning supported by suitable examples. The video discusses rules and properties of the chapter probability, and lastly it deals with some limited common simple questions with their solutions. Let's start. Introduction. Probability is the branch of mathematics concerning numerical description of how likely an event is to occur. Consciously or unconsciously, all of us use the phrase like almost uncertain, most probably, no chance at all, etc. We will find that all of them involve an element of uncertainty. The measure of uncertainty is called theory of probability. The study of the theory of probabilities is of great mathematical interest and of great practical importance. Here are some basic terms and concepts to be used in the chapter. Experiment. A process which results in some well-defined outcome is known as an experiment. If all the outcomes of the experiment are known in advance, but any specific outcome of the experiment is not known, then the experiment is called random experiment. Next is sample space. The set of all the possible outcomes of an experiment is called sample space. It is denoted by the letter S. Equally likely outcomes. If outcome of each and every element of an experiment have the same possibility of happening, then outcomes are said to be equally likely outcomes. Next word, an event. An outcome of a random experiment is called an event. In other words, an event is something that happens. Let's try to understand the meaning of all the basic terms discussed just now. The example taken here is throwing a Ludo dice. As we know, the dice has 6 faces, and in each face points are marked as 1, 2, 3, 4, 5 and 6. The first one is experiment. Since outcomes of a dice 1, 2, 3, 4, 5 and 6 are all well defined, hence it is an experiment. The next one is random experiment. Since all the outcomes 1, 2, 3, 4, 5, 6 are known in advance, but any specific outcome is not known. It means while throwing a dice, which point will occur is not known in advance. Hence, it is a random experiment. Next one is sample space. Sample space means arranging all the possible outcomes of an experiment in set form. And here all the outcomes represented in set form is named the set S. So S here represents sample space. The next one is equally likely outcome. Here we know very well that the chances or possibility of the points 1 or 2 or 3 or 4 or 5 or 6 are same or equal. Hence is called equally likely outcome. Next one is event. In this experiment, getting 1 or 2 or 3 or 4 or 5 or 6 as outcome is an event. Now I believe that the meaning of all these basic terms are clear to you. Here is measurement of probabilities. The probability of an event denotes the likelihood of its happening. It is written as P and within bracket E, where P stands for probability and E is an event. Hence, the probability of event E is equal to number of events favorable to E whole divided by total number of all possible outcomes. Next is elementary event. An event having only one favorable outcome is called elementary event. The next one is empirical or experimental probability. When the probability is based on an actual experiment, then it is called an empirical probability or experimental probability. The next one is classical probability or theoretical probability. When a repetition of an experiment can be avoided for calculating the exact probability, the probability so obtained is called classical probability or theoretical probability. And in our syllabus, this probability only is there. Let's understand these terms through suitable examples. The first example is tossing a coin. In tossing a coin, the probability of getting head is 1 by 2. Here, number of favorable outcomes is 1 only. Probability of getting tail is also 1 by 2, and here too number of favorable outcomes is 1 only. Since in both the cases number of favorable outcomes is 1 only, hence both the events are elementary events. As the definition says, in any event, if total number of favorable outcomes is 1, then it is elementary event. Let's observe another example in which a coin is tossed 100 times, out of which head occurs 57 times and tail occurs 43 times. It shows that the experiment is actually performed. Therefore, it is called an empirical or experimental probability. Let's take third example in which it's mentioned that a coin is tossed. and by formula it is obtained that the chances of getting head is 50% or 1 by 2, and the chances of getting tail is 50%, again 1 by 2. Here it is confirmed that the experiment actually is not performed. Therefore, this probability is called classical probability or theoretical probability. Now I believe that through these examples, the meaning of elementary event, empirical probability, and classical probability are clear, and we have to study only classical probability or theoretical probability. Here we discuss rules and properties of probability. The first one says that for any event A of an experiment, the probability is in between 0 and 1. Number B says the value 0 indicates impossibility of the event. It means if probability of an event is 0, that shows it is an impossible event. Number C, it says the value 1 indicates certainty of the event or surety of the event. Number D, the sum of probabilities of all possible outcomes is 1. For example, if you toss a coin, the probability of getting head is 1 by 2 and probability of getting tail is 1 by 2, and there is no other possibilities. Their sum is 1. Number E, for any event, the probability of A and the probability of not A are complementary events, where A dash or A bar means not A. Since probability of A plus probability of A bar is equal to 1 because they are complementary events. Hence, if PA equal to n, then PA bar is equal to 1 minus n. Let's discuss some common questions on the chapter. Question number 1. A bag contains a red ball, a green ball, and a black ball. They are all identical. A ball is taken out randomly. Find the probability of getting a red ball, then a green ball, and then a black ball. Number A. Probability of red ball. Since only one red ball is there in the bag, hence the favorable outcome is 1 and all possible outcome is 3. Hence the probability of a red ball is 1 by 3. Since the bag contains only one red ball, only one green ball, and only one black ball, hence the probability of green ball also is 1 by 3 and probability of black ball is also 1 by 3. Hence all these are called elementary event. Let's take another question. Question number 2. A bag contains 2 red balls, 5 green balls, and 8 black balls. A ball is taken out randomly. Find the probability of a red ball, a green ball, and a black ball. Since total number of balls in the bag is 15. Therefore, all possible outcomes equal to 15. Number A. Probability of red balls. Since there are 2 red balls in the bag, hence favorable outcome is 2 and all possible outcome is 15. Therefore, probability of red balls is 2 by 15. Similarly, we find the probability of green balls and black balls, and we get probability of green balls 5 by 15 and simplified to get 1 by 3, and probability of black balls is 8 by 15. Let's take another question. Question number 3. 30 identical cards are marked 1 to 30. One card is drawn at random. Find the probability of number A, getting a multiple of 4 or 6. From 1 to 30, total of 9 cards are there, in which the number marked is the multiple of 4 or 6. Hence, the favorable outcome is 9 out of total possible outcome 30. Therefore, probability is 9 by 30, and in simplified form it is 3 by 10. Next question, number B. Find the probability of getting a multiple of 3 or 5. Here are the numbers which are multiple of 3 or 5 in the range 1 to 30, and total number of 14 numbers are there. Hence, probability of getting a multiple of 3 or 5 is 14 by 30, and in simplified form it comes 7 by 15. Next, number C. To find the probability of a multiple of 3 and 5. The multiple of 3 and 5 means the multiple of LCM of 3 and 5, and that is 15. And in the range 1 to 30, 2 numbers only are there, that is 15 and 30. Therefore, probability of getting multiple of 3 and 5 is 2 by 30, and in simplified form it comes 1 by 15. The next one, number D. To find the probability of getting a prime number. These are the prime numbers shown in the range 1 to 30, and total of 10 such numbers are there. Therefore, probability of getting a prime number is 10 by 30, and in simplified form it comes 1 by 3. Next question, number E. To find probability of odd multiples of 3 in the range 1 to 30. Odd multiples of 3 are 3, 9, 15, 21 and 27, and total of 5 such numbers are there. Therefore, probability of getting odd multiples of 3 is 5 by 30, and in simplified form it is 1 by 6. Part 1 of the chapter Probability is over. In this part of the video, I discussed about probability, its meaning, some basic terms and concepts with examples, measurement of probability, and took some questions and solved. In next part, I'll continue the chapter. Thank you.